students. Today we are going to discuss the introductory part of Introduction to Linear Polynomial Chapter 2 from Class 9 CBSE syllabus. We have learned about algebraic expression in earlier classes. Let's discuss with some examples. 2x plus 3. It's an algebraic expression. It has two terms. The first term is 2x and the second term is 3 and the letter number is x. 3y minus 2 is another example. It has also two terms. First term is 3y and the second term is minus 2 and the letter number is y. These are some special type of algebraic expression called linear polynomial. In this chapter, we will study more about linear polynomials. Let's consider a few more examples of linear polynomials. 5x plus 7 is a linear polynomial. 2y plus 9 is a linear polynomial. Here x and y are the letter numbers. Now instead of the word letter number, we are going to use an alternate word, variables. Variables. So in the first example, the variable is x and in the second example, the variable is y. Is it clear? Let's consider a few more examples of linear polynomials. 5a minus 7. Here what's the variable? A is the variable. It has also two terms. 5a is the first term and minus 7 is the second term. And coefficient of a. What is the coefficient of a here? It is 5. So coefficient of a is 5. Here what is the coefficient of y? It is 2. Here what is the coefficient of x? It is 5. And what's the constant term in all these cases? See, in the last example, constant term is minus 7. Here the constant term is 9 and in the first example the constant term is 7. Now let's see some other algebraic expressions. X square plus 3x plus 4. See, it's also a polynomial and the variable in this algebraic expression is x. Here how many terms are there? First term is x square, second term 3x and the third term is 4. And what's the coefficient of x square? Coefficient of x square is 1. 1x square is x square itself. So coefficient of x square is 1. Coefficient of x is 3 and constant term is 4. And this type of polynomial, see, look at the expression. Here the power of x is 2. Here the power of x is 1. And the highest power is the degree of the polynomial. So here the degree of this polynomial is 2. In the previous cases there the degree was 1. So it is called a linear polynomial. But here the degree is 2. So it is called quadratic polynomial. Let's see some more examples of quadratic polynomial. Y square minus 9. This is a quadratic polynomial because the degree of this polynomial is 2. But here y term is missing. So we can rewrite it as y square plus 0y minus 9. So what's the coefficient of y square? Coefficient of y square is 1. What's the coefficient of y? It is 0 and the constant term is minus 9. Hope it's clear. Let's take some more examples of algebraic expressions. X cube minus 4x square plus 3x plus 2. See, it has 4 terms and the variable is x. First term is x cube, second term minus 4x square, third term 3x and the last term is 2. And here the power of x in the first term is 3 In the second term, the power of x is 2. Third term, power of x is 1. So here, the highest power is the degree of the polynomial. So here, the degree is 3. Such type of polynomials are called cubic polynomials. And here, constant term is 2. And we can rewrite it as 2x raised to 0. Because x raised to 0 is 1. 5y square plus 5. Suppose this is the expression. So we can rewrite it as 5y square plus 5y raised to 0. So what's the coefficient of y raised to 0? It is 5. Or what is the constant term? That's 5. Hope it's clear. And here, what's the coefficient of x cube? It is 1. Coefficient of x square is minus 4. Coefficient of x is 3 and the constant term is 2. Now let's discuss exercise set 2.1 from page number 18. Our first question is find the degrees of the following polynomials. Here 4 different polynomials are given. First polynomial is 2x square minus 5x plus 3. And here the variable is x and the power of the variable in the first term is 2, second term is 1 and the third term is 0. So highest power is the degree of the polynomial. So in this case degree is equal to 2. Degree equal to 2. Now second case, y cube plus 2y minus 1. Y square term is missing. And the highest power is the degree of the polynomial. So degree equal to 3. Here the third question is minus 9. Minus 9 means minus 9x raised to 0. So what's the degree? Degree of this polynomial equal to 0. Here 4 is at minus 3. It is a linear polynomial because the degree is 1. Here it is not mentioned but z means z raised to 1. So 1 is the degree of this polynomial. Our second question is write polynomials of degree 1, 2 and 3. Degree 1 first we will discuss. Degree 1 means x plus 2. We can take a minus 3, y plus 5 or simply b. They are the examples of polynomials of degree 1. Next, degree 2. X square is a polynomial of degree 2. 3x square plus 5 is a polynomial of degree 2. 2y square plus y plus 5 is a polynomial of degree 2. Now degree 3. (3x cube) is an example. Here 3 comes means degree is 3. 2x cube plus 9. See, degree 3. Another example. Y cube plus y square plus y plus 7. Highest power is the degree. It's an example of a polynomial of degree 3. Our third question is what are the coefficients of x square and x cube in the polynomial x raised to 4 minus 3x cube plus 6x square minus 2x plus 7. So first coefficient of x square we can find out. So take the x square term. X square term is 6x square. So coefficient of x square is plus 6 or simply 6. Now we need to find out the coefficient of x cube. X cube term is minus 3x cube. So the coefficient of x cube is minus 3. Hope it's clear. Moving to the next one. The question is, what is the coefficient of z in the polynomial 4z cube plus 5z square minus 11? Here we need to find the coefficient of z, but z term is missing. So we can rewrite this as 4z cube plus 5z square plus 0z minus 11. So coefficient of z is 0. Moving to the last one. Here the question is, what is the constant term of the polynomial 9x cube plus 5x square minus 8x minus 10. Constant term is minus 10.